Okay guys, so I am going to fill in these notes and talk through them with you because this is a new portion of our unit and I want to make sure that you're understanding the new stuff as we go along. So I'm going to do this with you as if I were at the board at school doing this in front of you. So we're going to start talking about lenses. And we're going to talk about two different types of lenses. We're going to talk about a converging lens and a diverging lens. I drew the pictures here. Converging is also called convex, and diverging is called concave. See, it caves in like that. You can notice that a convex lens, a converging lens, is thicker at the center, than it is at the edges. So it goes out. Okay, so thick at center, thin at edges. Edges being here, okay? The tops and the bottom. Concave is thin in the middle, right here, and thicker at the edge. So thin middle, thick edge. Okay, so you can see the difference between the two lenses that we're going to be talking about. And then I wrote here, rays spread out. When they enter sorry about the shadow. When they enter here, they'll actually end up spreading out like that. Okay, and we'll talk about converging as well. Most of the practice problems you will see will have to do with a converging lens like this. We call these ray diagrams. Basically what we're saying is that an object is on the side of the lens and we want to know what it looks like, what the image is going to look like on that lens over here. So this is a ray diagram. This is the lens. Okay, so I'm going to label that lens. This is the axis. We call it the principal axis. Okay, so I call that PA or principal axis. Okay, so that's the line in the center of the lens going that way. For each of these problems, you're gonna have an object. So we're gonna use arrows to represent our object. So this arrow right here would be our object. It could be anything. Oops, sorry, can't spell. Okay, it could be anything like a pencil, right? Okay, I don't have a lot of stuff here. A pen, whatever else. All right, so if something is standing, a person, whatever, something is standing in front of a lens, what is the light gonna do to it to reflect an image or refract or bend or whatever? So with this lens, we're gonna have a focal point labeled F and another point called 2F, and it's going to be like that on each side of the lens. Okay, so for each of these problems, you'll have F as the focal point, and 2F is basically double the focal point. Okay, so to draw these diagrams, this portion of the notes right here is going to be kind of the centerpiece of what we're doing. So for the drawings anyway, it looks complicated at first, but once you do it a few times, it'll get easier. So I'm going to write these through and then I'm going to tell you some phrases that I like to use. So the first step you're going to do is draw a line parallel to the axis. Parallel to the axis and then to the lens. Okay, so the first line you're going to draw is going to be parallel like that to the lens. That's all we did. Extend the line through the focal point on the other side of the lens. Okay, so this step one is just a straight, you start from the top of the object and you draw a parallel line to the lens and then you extend the line through the focal point. Let me get my ruler. through the focal point on the other side of the lens. Okay, so that was step one, and that parallel line was not the best. Okay, there you go. Parallel line through focal point. Okay, so that was my first line that I drew on my ray diagram. Step two says draw a line through the focal point to the lens. Okay, so I'm starting at my object again, and I'm gonna draw, this time I'm going through the focal point here. So draw a line through the focal point to the lens. Extend the line parallel to the axis on the other side of the lens. Okay, so now here we're going to go from the line we just drew, and we're going to run that line parallel to the axis. Again, this is an axis and this one's parallel. All right, step three, the point of intersection. Okay, so right here, you see where these two lines that I drew, parallel through F and then through F and parallel, they intersected right here. The point of intersection is the top of the reflected image, is the top of the reflected image. Draw an arrow from the axis, principal axis, to the intersection. Okay, so that means you're going to go from the axis and you're drawing an arrow to where it intersects right there. So you can see that this is the object, and after you draw your lines, you can see that it creates an image. So this arrow would be the image. Right here I had the word draw, but I just used this diagram to show you what that meant. So right here I'm going to actually write my steps. So the steps we just did to draw the ray diagram, this is what I want you to remember. Parallel through F, and then through F, parallel. All of these words can be seen through this phrase. So all I did was draw parallel through F, and then through F, parallel. It showed me, based off of where this object was, it showed me where my image was going to come up from the lens as the light refracts through the lens. So you're going to be practicing with those a little bit later on. So I just wanted to make sure you had this portion kind of memorized as you're going through these. So remember, over and over and over, parallel through F, parallel, parallel through F, F through F, parallel. And once you do that many, many times, you'll kind of see a trend in where your images are gonna come up. On Friday, you guys did watch those videos, hopefully, and we learned some new formulas. So one of those formulas was the mirror lens equation. I put still works for lenses because usually we do this with the mirrors first. So, but anyway, so this is the formula. 1 over F equals 1 over DI plus 1 over DO. On your next page, you also have the magnification equation, which is M equals HI over HO equals negative DI over DO. Okay, so you have some examples here, and you're gonna draw the ray diagram for each of these. Oh, well, sorry, this is just one example. You're gonna draw the ray diagram, you're gonna find the image distance, and you're gonna find the image height. And then we're gonna answer this question, is it real or virtual? And I'll go into that a little bit more in a minute. Okay. So if I draw, it says a 3 centimeter high object is placed 32 centimeters from a convex lens and has a focal length of 8 centimeters. Find the image distance, image height, and if it's real or virtual. Okay, so 3 centimeter tall object. 3 centimeters is very little compared to 32 centimeters. Okay, so you kind of want to represent the arrow that you're doing just as if like 3 compared to 32 is very small. Okay, so 3 is very small compared to 32. So you want to make sure you do represent the arrows the best you can. It says it has a focal length of 8. So if I say this from here to here is 8, that's going to kind of be my scale on how I'm going to draw my arrows. So that's my focal length. This is placed 32. So if this is 8, 16, you know, 32 would be somewhere back here. Okay, it doesn't have to be perfect, but just represent it the best you can. 3 centimeters tall compared to 8 is going to be about that long. So my arrow is going to be very short. Okay, so that's my object. I'm going to draw my ray diagram. Remember your phrase. Parallel through F, and then through F, parallel. Okay, so right here, if this is my, from here to here is 8, that same distance would be 2F. Okay, so I'm going to do that on the other side of my lens as well. So this would be F, and this would be 2F. Okay, so now I'm going to draw my parallel through F and through F parallel. So I'm going to put this line. Again, this is just a sketch to show you what your image will end up like. It's not a perfect draft for sure. Okay, so I went parallel through F, and then I'm going to go through F, hit the lens, and go parallel here. So it's going to be very small and upside down. Okay. Okay, so now we're going to use our formulas to find the image distance and the height. All right, so first we have to look at what we're given. 3 centimeters high, well, that's the height of the object. So that's HO, okay? It's placed 32 centimeters. Well, that's going to be the distance of the actual object. So that's DO. Then it says it has a focal length of 8. So that's going to be your F. So now you can look at what you have and what you need to find. I'm looking for image distance. I'm looking for DI. I don't know what that is. So I'm going to go to my formulas. I'll write the other one up here so it's on the same page. Okay, so here's the 2 formulas you have. And I'm going to choose the top one to solve for image distance. 1 over F equals 1 over DI plus 1 over DO. All right, I have a focal length of 8. So I'm going to put 1 over 8 equals 1 over DI. DI is what I'm looking for, plus 1 over DO. Well, we said DO was 32. So I'm going to get my calculator. I do not like fractions, so I am going to get rid of my fractions. And to do that, all I have to do is divide. So my first one is 1 over 8. So 1 divided by 8 is 0.125. I'm going to bring everything else down. I'm going to get rid of the 1 over 32. Okay, these are kind of crazy numbers, but don't let that bother you. Okay, 0.03125. Okay, so because I'm adding here, I need to subtract that number over. It cancels on this side. And you can see my calculator there, I think. Okay, 0.125 minus 0.03125 is 0.09375 is equal to 1 over DI. Well, I'm not done because I don't want 1 over DI. I just want DI by itself. Again, there are several ways to solve this problem, but I multiply by DI. Okay, that cancels here. Then I'm left with DI times 0.09375 equals 1. And then I have to divide by this number to cancel that. So DI equals whatever this is in your calculator. So let me pull this over here so you can see. 1 divided by 0.09375 is equal to So DI equals 10.7 centimeters. Okay, so, which actually, if we go back up to our picture, and I know my arrows are very small, but this was 8, so the distance of the image would be about 10, which makes sense. So I like that answer. Okay. Now it says to find the image height. So we're going to go back to our formulas up here. HI, this is HI. Only this one has HI in it. So I'm going to use HI over HO equals negative DI over DO. All right, plug in numbers. HI I don't have, so that's what I'm looking for. HO, if you go back to your original problem, we said HO was 3 equals negative, DI. Negative DI is a negative 10.7 over DO, distance of the object was 32. This one's a bit easier to solve. So you just take, let's see. So I'm going to simplify this side first. So negative 10.7 divided by 32 is negative 0.334 equals HI over 3. And then I'm going to multiply both sides by 3 to cancel here. So HI equals times 3. Right there, you can see it in my calculator, if you can see that, negative 1.00. So the height of the image, and you can see how much smaller my arrow is there than it is there. So my object was 3, and my image is negative 1. Well, what does the negative mean? The negative means it's pointing down. So is it real or virtual? Well, if you watch those videos, I think that was in your videos, anything that's upside down, that's called inverted. Anything that's inverted is real. That's a real image. And we'll go into more detail if I need to on that later. Okay, so those are your notes, and I hope that helps you to answer some of those problems on the next, I don't want to say homework because it's not due, but the practice problems that I put up there as well. Okay, good luck.